Hello everyone, I am Vaishnavi Jetesai, Assistant Editor for Emerging Technologies for ETCIO. Welcome to this webinar by ETCIO and ThoughtWorks, Unfold Your Data Platform for Generative AI Success. Large language models are widely viewed with the potential to transform the productivity of companies. But the caveat here is that they need to be used quite thoughtfully with a clear and an adaptive strategy as well. We understand that business leaders are excited to navigate this landscape and they are exploring key solutions that streamline their adoption of Gen AI. Over the course of this discussion, we will deep dive into how generative AI revolutionizes industries, thereby boosting productivity. How business leaders can seek strategic, mindful adoption for competitive advantage in a transforming landscape, and the emerging architectural patterns crucial for building these successful AI-powered products. I'm joined by esteemed leaders today. Bharani Subramaniam, Chief Technology Officer, India and Middle East, ThoughtWorks. Ashwin Sugavanam, Head of Data and AI, India and Middle East, ThoughtWorks. And Srivatsa Subbanna, Head of Intelligent Automation and AI for Axis Bank. Welcome, Bharani, Ashwin, and Srivatsa.
Pleasure to be here.
Happy to be here, Vaishnavi.
I just all asked to host you as well. I would request the audience to leave your questions in the chat box, and we will address them to the best of our abilities at the end of the session. I repeat, if you have any questions, kindly leave them in the chat box, and we will make an effort to address them to the best of our abilities at the end of the session. So let's begin. I now invite Bharani to help us understand the architectural nuances required to embark on the Gen AI journey. Bharani, the stage is all yours.
Hey, thanks, Vaishnavi. Right. Okay, so for the next 20 minutes, I'm going to take you to a journey of what we have collectively observed with a number of Gen AI projects across the globe. And there is a clear emergence of a patterns in the architecture, which is what we would highlight. So for this talk, you don't need any prior expertise or experience on Gen AI. And if you stay with me for 20 minutes, by the end, I'm sure you would have learned something. So let me know. So with that, I just want to start from the beginning, the one that started it all. If you recall the whole movement that we had with big data, and it all started with the Hadoop paper. Similar to that, you could say that the whole LLM evolution started with Google accidentally discovering this architecture of transformers way back in 2016 when they are working on something else in the natural language processing, right? So that is the one that started all this. But if you look at now in 2024, the whole tooling and platform and even products out there, we are seeing such an explosive growth, and this should not be a news for any of us in the call, right? But if you take a step back, right, you can relate this to what happened to the evolution of life. Millions of years ago, we had this Cambrian explosion moment where everything was right at the right moment of time. We had explosive growth of organisms. And we have seen this in our industry as well, right? A number of times we have gone through this journey where there is explosive growth in, let's say, JavaScript framework. So much so that few of us called it JavaScript fatigue because it's so hard to catch up, right? And at some point of time, the same happened to cloud. It started very small, and this is a picture I could fit in a slide of the entire CNCF landscape. We have seen this explosion happen. But if you ask this question of why is this explosive growth happening especially in Gen AI, right? Like, why is it important now? If you stay on the question a little bit longer, you realize that we've always been told, right, from the whole big data era and moment, that the data is going to be a moat, right? Data is what separates you from the competitor. While we achieved to some level of degree with the big data ecosystem, now with the era of LLM, there is this promise that you can use your data and really truly distinguish your offering so that you build this moat for your enterprise, right? That I think is the fundamental reason why there is so much of explosion and so much of hype around Gen AI, because of this fact that if you have a data that nobody has, you have an edge over others, right? So keep that in mind. We'll keep coming back to this. So all of this is the context for how we are architecting our applications for enterprise. And from now to, let's say, the next 15 minutes, I'll take you to a journey where the architecture is not built as one scary big diagram. I'm going to start from fundamentals and really building blocks, and then slowly add complexity and see, what we are observing. So let the architecture emerge, right? I don't know how many of you have heard or read this book. This is a fantastic book by John Hall way back when he did the study on systems. And this is one of my favorite quote from the book, is that if you have seen any complex system that is working, invariably it has evolved from a simple system that worked, right? You cannot directly invent a complex system and make it work. That's really not possible, right? And we will see it how it evolves. So for this argument and this presentation sake, I'm going to simplify that LLM is extremely complex, but for most of us who are application architects and application users, we treat LLM as the basic building block. It is very simple. I give you some prompts and some data, and I expect some response, right? So that is the basic simplistic system. We know that this works. Now let's see how we are going to add complexity and the architecture evolves with that, right? So remember, I said all of this is because you have your data that nobody has, right? Which begs the question: then LLM has no clue about the data that is in your enterprise beyond login, beyond firewall. So how are you going to make use of this enterprise data, which is not what is there in internet, and it is not what LLM is trained on? So what are the options? What are you going to do? How are you going to address this problem? And looks like we have three choices to make in front of us. The first one, obviously, you can say that, what, I'm very unique. I'm in this pharmaceutical, I'm in this BFSI sector where my bank is so different. I need something fundamentally new, and I can train a model from ground up. Very expensive, very costly to do. Very few people even attempt to do this, right? So that's training the model. The next one is a little bit approachable. You can take a model and then fine tune for your own data. That's an option. But the option 99% of us take is that I just take the generic model, because the models keep evolving over time and they are pretty good with it. Somehow I need to use my enterprise data using this technique called RAG, which stands for Retrieval Augmented Generation, and I will make it contextualized. So that's how, if you pick any application that you have built using LLM, invariably you will use the RAG technique, right? That's given in this period of time, right? So there are three options to do, right? Now, I'm going to pause and take a little detour because this is something that not many people explain in a very simplistic way. If you're working with LLMs, you would come across this term called embeddings, right? So what are embeddings? It's not an embeddings of the picture that you see. So the best and simplistic way to explain embedding is, let's take this picture. If a human sees it, okay, I have a cut orange, an avocado, grapes, and all healthy fruits there. But map it to your domain, irrespective of which background or which industry you come from. If you look at your systems, you might have thousands and thousands of structured schema and table that is designed to have representation of your industry. But for something like an image, for something like audio, for something like an unstructured text, right? It's in a higher dimensional space. I can't fit this in a relational model. neither in a key value store. So somehow I need to say that it is not a whole orange, it is sliced into half, and I can clearly see it is juicy. How do I represent all this in a system, right? And that's where the embeddings come from. Embeddings are nothing but sequence of numbers, integers or floating point mostly, with variable length. The meaning of this vector is only for the machine learning models. For humans, these are just numbers, right? Um, and the fact that you cannot create the numbers by hand, you need another model to actually decompose this higher level concepts uh, to a number that can be easily understood, right? You can't keep explaining how a human reads an image or a text. You need a way to easily crunch them in the computer. And that's why these vectors or arrays of number is called embedding. And that begs the next question. If you have lots and lots of data in your enterprise and you have lots and lots of embeddings, you need a store to search. If somebody asks, okay, I have a large warehouse, I want this order to be fulfilled, you need an efficient way for you to locate and retrieve, right? And if the orders are something like, I want something that looks like purple, like you need to have some kind of a similarity search. And this is very different from if you come from the relational transactional model, which is very how do I put it? You have a BT index and you exactly know what to look for, as opposed to here, it's a search in higher dimensionality for similarity, right? And this is the reason why you can't use any databases. You need to have a vector database. And that's the reason, right? So you're connecting an embedding, you need a model, you need to have a vector, and you also need a vector database for this reason. All this is good. Where are we with the emergent architecture, right? Remember, we had this very simple Lego block, prompts and response, and an LLM. Now the architecture becomes, I have the moat, and moat is my data. I can't directly use the data because it's higher dimensional data. Even if you have structured data, unstructured data, you convert all of that to embeddings with an embedding model, and you store them in a vector store. So far, so good, right? But it's all, if you look at the diagram, it's all disconnected. So you need some component in your architecture that kind of orchestrates all of this. And hence you have the orchestrating layer, right? Which is good. Now, begs the question, it's okay for you as a user to use LLM all the time because I need to give input, take response back, and so on and so forth. But if you think you are building an enterprise app, it's most likely that your users are going to use the same app day in and day out. And you're going to have, if not millions, at least thousands of users to begin with. And then you scale. So the economics of, your costs of invoking the LLM API, that keeps growing up, not down. And they are charged by the tokens. And we all know this. So we all have this notion that, okay, let's put a cache, like how we put a cache in front of a database. But here is the problem. In a traditional world, you can deterministically find I'm looking for banana, and banana is this cache. Do I have banana in the cache, or should I go to database? But in an LLM world, I will describe banana as a whole banana. Someone will describe it as, oh, you know what? I want an organic banana. So in that context, you need a semantic search, right? Not just a normal search. Once again. So the picture now becomes, the orchestrator may or may not call the LLM. It may go through a layer of a semantic aware cache, right? So that A, your applications behave faster, more responsive. It's not going to the LLM. And B, it's cheaper for you, right? So that's how the architecture has now emerged. Now let's change the gear. Every project is a data project. I'm sure Ashwin will agree with me. 80% of all these engagements involve this complex and sometimes mundane and boring job of transforming, cleaning, and classifying to some degree structured, unstructured data. So goes without saying, you can't directly use an embeddings model, put that via a data pipeline. And that's really, really key, because your transactional systems will be producing data and you need to keep updating your vector store with it. So it's important it goes via the pipeline, right? So there comes the pipeline. And let's not forget the most important thing why we are here. We want to build the next big, awesome AI-powered, Gen AI-powered app. And then you have the app, which is giving you a prompt and getting the response. Now, I hope audience is there still with me, and then I'll keep going. We've all heard of this SQL injection, don't coin SQLs by hand. The same vulnerability exists with your LLM. Now, it's possible there are so many side channel attacks where somebody can inject unwanted malicious code in the prompt or malicious prompt itself. So like OWASP has top 10 security vulnerabilities for your APIs, there is also OWASP top 10 for LLM. So you need some way to protect your application and your brand reputation from these unwanted side effects. And hence, you can't directly send prompts to the orchestrator from the app. It goes via next extra validation. It can be for malicious, to avoid malicious content. It can also be that I'm working with PII, IP protected data. I want some architectural component that protect users from themselves, right? Somebody is not aware that according to my company policies, this data is proprietary. Then you can stop at this layer that even if different apps with different team who doesn't have the knowledge does this, you can stop at this prompt validation so that you protect your application, right? So that's another reason why you need to validate your prompts before it reaches the LLM, which is good. But then what happens if LLM gives you a response that's inappropriate, right? Um, there are n number of reasons why it can do this. It's a thing, if you want LLM to do something and you put an app, the users are always going to find innovative ways to break it, right, and make it do something else. So it's possible that LLM will give you a response that is not appropriate. So not just validate your prompts, you also need to filter the response, right? So it's pre-processing and also post-processing before you consume in the app. So time to look at the Bible again, system Bible again. This is my second axiom. We took something that is simple and we kind of stretched across all dimensions and made it super complex. Now the system is no longer simple, right? If you have stretched it so much and expanded in all dimensions, so visually it used to be this, now it is this, right? It is, even in the Lego block contextual diagram, it's so complicated, right? And it will not behave like a simple system. So what do we do, right? And there needs to be some way to help and deal with this complexity. This is just the layer where for each of the blocks, I've just given one or two things that we can use. For example, so the whole prompt validations and response is just a part of the larger number of guardrails you would need. And Nemo is one of the famous projects from NVIDIA that allows you to do it. And like that, there are other options that I've highlighted. But the fact remains that this is very complicated, right? And how do you deal with this complexity? The first answer is you definitely need a lot more observability on this, right? And observability in microservices world is one thing. Observability in LLM is a notch or a couple of notches ahead, or rather more, is because for the same input, the system can give you different response, not because LLM is hallucinating, but because your embedding model may evolve over time. your vector data may change over time, the output will also change, right? So we need to be a lot more careful when observing such system, and hence there are new standards coming up on top of open telemetry, right? So that's with observability. This is the part where most of people who want to scale from a POC to production, they miss this part, is that your prompts over time, they degrade in performance because of all the reasons I've just said. Your data, your vector store, your model, or even the LLM itself changes over time. And the embeddings model that you have, you also need to evaluate if you have different kinds of data, or your app is now solving different kinds of problem than when you started with. You need to continuously monitor and evaluate how my prompts and models are working over time, right? Keeping my data set constant. So you need to have a pipeline in your CI that runs a week, a month, or something like that, so that you know how my application is performing with more data and better models over time. Because fundamentally, LLMs and the whole ecosystem is non-deterministic, right? That's the third. The last and the final part, before we open up for the question, is that all this is great. What if you want to take your own control and self-host? When I say self-host, I'm not talking about I'll take the model and put it in AWS SageMaker. That's also self-hosting. But if you have a stricter, more controlled environment, there are options coming up. Olama is one of the options where you can self-host your own model in your own infrastructure and scale it, right? In this case, Olama, you can do it on your laptop and host it. So that's how the architecture, what is simple for an end user to have a chat-based interface, morphs into a complex distributed system with many, many moving parts when you wear the hat of an application architect, or an application designer. That there are n number of pieces that has to come together to make things work, and this is just the beginning, right? Like, I'm sure this is even evolving more and more. For example, if over time, if your length of the prompt is increasing, doesn't mean you're going to get better response. So there are new techniques of compressing the prompts that are also coming up. So this space, if I listen to my own talk in a month, I have to edit a few things. That is the pace that we are working with. There are so many moving parts, and I'm sure Ashwin and Srivatsa is going to like spark more thoughts and more conversations. But I thought this is what I had to start as a base and reset everyone's knowledge and expectations for the rest of the 20-30 minutes. So open to questions. I have Vaishnavi, how much time do I have to answer questions, if at all?
You have ample time. We will take all the questions in the end, definitely.
Awesome.
So that everything is, you and Ashwin get equal time to, we can grill you equally.
Okay, awesome. Looking forward to that.
So that's the aim. Yes, I'm on the audience's side at that point. So
Awesome.
thank you, Barney. Thank you for setting the foundation so well. And as you rightly said, that the landscape is so dynamic, and we go to sleep, we wake up every day, there's something new announcement coming in and new changes coming in. So thank you so much for enlightening us on the architectural nuances. I now invite Ashwin and Srivatsa to join me for a conversation on the potential of Gen AI and how leaders can better navigate this dynamic landscape with clarity and strategy. Ashwin, Srivatsa, I'm so glad to have you on board for this conversation.
Thanks, Vaishnavi, for
Thanks, Vaishnavi. Glad to be here.
Thank you for taking time. How is generative AI being applied across different industries? So that's a point of curiosity for everyone, because everyone wants to learn from their peers. And how does it align with their respective organizational goals? And if, when you answer the question, if you could provide some specific examples of successful implementations, that would be helpful. So Ashwin and Srivatsa, I request both of you to take this up.
Sure. Let me probably get started and then hand it off to Srivatsa. So in my experience looking at different enterprises across industries, I'll take a few examples to walk us through, what are the different use cases people are handling, right? Like, so the first one is a very unique industry of hiring, right? India is the resource capital, as we call it, right? Like we have so much talent and young talent available that, we are the resource capital of the world. Uh, we had an opportunity to work with one of the temp staffing companies of India, the largest one. And the biggest thing that they wanted to do, and which was aligned to their organization goal, was how do they improve hiring efficiency, right? So there are two aspects or two dimensions on which they measured it. One is the turnaround time of hiring. So basically, whenever they get a request, how fast can they turn it around? Because there is huge competition waiting to staff the same position. And the
Mm.
second thing is the quality of hiring itself, right? How quality of staffing, right? So how can they ensure that whatever profiles they're giving to their customers actually matches their customers' needs as such, right? So
Mm.
that's the
Mm.
problem that this hiring company is trying to solve. And the biggest reason they're trying to solve this is because they want to turn it on the head, right? Like when the people are trying to compete on this space, they really want to do this so that they continue to maintain their supremacy as the largest temp staffing company in India. So if I just take how does generative AI help in this scenario, right? Like if you look at it, two dimensions here. One is most of the blue collar workers don't have a profile like you and me. Most of them, the profile itself is captured by a recruiter at a panwala shop at the end of the day, right? Like, and that's where they would have a conversation and the profile is actually captured. But
Mm.
this enterprise has been in the business for a long time, but they never captured this. But now, with the help of generative AI, they're actually able to capture it through a WhatsApp chat. For instance, the recruiter just on the WhatsApp chat when he's having this conversation, and then the profile comes into their database, right? So now, truly, they can own those profiles, right, for a long, long time, and then mine them with what is called similarity search, right? So when Bharani explained the banana example, right? Like, okay, that is a problem that we in the tech space have faced for a long time, where we ask for a profile on Java. Most of the times, you get a profile which is JavaScript. That is similarity, right? Like that is called semantic similarity based search is not employed in that scenario. It's basically a keyword search that people
Mm.
employ. Whereas here, you need what is called a semantic similarity search, whereby, like I ask for a delivery executive, and I am a recruiter from who's recruiting for Zomato, right?
Mm.
I don't want an ThoughtWorks delivery executive. I really want, or an Accenture delivery executive. I really want a Zomato delivery executive. So the context is passed in, and then the similarity is used to search for a particular profile, and the profile is brought back. So this actually helps the organization get better results back to the
Mm.
customers. And also the entire turnaround time that I was talking about, where there were a lot of humans involved in this, doing this recruitment filtering and interviewing. They're also looking at automated interviewing processes to screen profiles through as such, right? So they want to have a stage where there is an automated interview that happens using a bot, and the bot is contextually asking those questions. It's
Mm.
not a dumb bot, it's actually a contextual bot as such. So this is one fantastic example I have seen in the recent past. Happy to have worked with this customer as well. The other big industry before I hand it off to Srivatsa is pharmaceutical or life sciences. So life sciences is again going through a lot of change, especially with COVID. People wanted to reduce the time it took to launch drugs in the market. Most of the time it takes for launching a drug is basically during the research process as such. And even
Mm.
in terms of cost, if a drug is $100 in worth, there's only $1 that they use in manufacturing the drug. $99 is actually spent in the research side of the house as such. So one of the key things that we were involved with a life sciences firm, is to help the researchers actually shorten the cycle that they use to do the research as such, because there's a lot of research that happens across within an enterprise itself, and the
Mm.
data is actually not shared.
Mm.
So it's shared, they cannot search for it because again, they want to search, basically look at, okay, which target will attach to which, protein, right? That is how people come up with drugs that me and you use in the end of the day, right? Like, so they want to know how does this protein attach to this target. So when they have to do that, they actually search using compounds. So compounds are simple things we would all learned in our chemistry in school days, like ethanol, whatnot, right? You just draw a compound which is COH and you are able to search for it. That capability is something that with the advent of generative AI, people are actually able to use now. So what happens is you're able to quickly filter down to the research, past research, probably that might have happened within your enterprise or outside your enterprise, leverage it and start your process from there. So you're eventually reducing, the cycle time that's used. And the last thing that I'd also like to mention is in terms of a generics market that India is, a big generics market in terms of pharma itself, we want to get each generics company wants to get a drug 10 years before the patent is expired, right? Or 15 years before. They want to expand, kind of be able to predict which is the one that they should, you know, uh, go after. What is the price point they have to go after, where they should launch, which markets they should launch, all of these, right? So if you look at this intense document retrieval, collation, reasoning that happens in human brain. And this is where again, this is one use case where again, some of the generics are big generic players are looking at using generative AI to solve this. Over to you, Srivatsa.
Yeah, thanks.
Thank
Thanks,
you.
Ashwin. I think Ashwin has covered the broad categories of problems that we are looking to solve with generative AI, right? So whether it is using a chatbot or semantic search, I'll focus on some specific examples in the BFSI space, right? So if you look at how data is used to solve problems in banks, they neatly sort of fit into four categories. The first is the customer, anything related to the customer. Second is operations, how we improve our operations. Risk is a big part of running a bank. And then there is compliance. We're a highly regulated industry. So from that standpoint, where we stand today, there is a lot of potential for using generative AI on the operation side. Specifically, for example, we find that we've all used chatbots with banks, and the general experience of using a chatbot is not good because the ones that run on older technology, they rely on keywords, they don't understand context, and that's where generative AI comes in. When you combine it with the semantic search, I can search a knowledge repository based on the context and then sort of come up with responses which answer that question in that particular context. So such a chatbot is very useful even for branch operations, right? There are many people who walk up to branches today and they end up spending a lot of time waiting because there isn't one single person who understands the processes or the products that a bank offers. So a chatbot which can quickly respond to customer queries around specific processes. For example, charges on NEFT if it's done at a branch versus if it's done via phone. Like these are common questions that people in the branch get, and it's not. And there are many products, and there are many such questions like that. So it's really hard for people on the ground to know these things, uh, across all the products. So that's like one use case which is out there. The other area is contact center. So when we talk of contact centers, and again, call centers, contact centers as an industry see very high churn. So people are there, it takes maybe 2-3 months to train them, and they leave in 5-6 months, and the whole process starts again. And that's another frustrating experience that customers have when
It
they
is.
when they call contact centers. Either they're not directed to the right person or they don't get enough information. So that's another area where something that can assist contact center individuals in real time. As a customer is asking questions, can that be transcribed, summarized? We use semantic search. We retrieve the answer, make it available as cues for the person working at the contact center. That automatically results in customer being happier because they're getting the responses faster. It's also good for organizations because the what we call as AHT, the average handling time, comes down, the amount of time spent on a call, right? So that's, again, it aligns with the organizational goals to have more calls answered per day at a contact center executive level. One interesting use case, again, this is more on the customer side, that I have come across, is that of customers being able to find out their own spend patterns, right? So one of the things that has happened with the advent of UPI, the negative is our bank statements are very cluttered. There is a lot of information in them. And if I want to find out exactly which category I have spent more money in a month on, or how does it sort of line up with my budget, right? It's a very basic use case. It drives a very high level of customer satisfaction when implemented, but at the same time, it's been very hard for banks to do it. They show you graphs. Sometimes there isn't enough information available in the statements, right? Because it is sort of unstructured data. So in that case, again, something like an LLM is able to sort of understand the context and sort of able to answer questions on your bank statement. So these are like some of the broad use cases that we see in the banking industry.
Thank you, Srivatsa. Stay with me because I have a follow-up question on the same. So, what are some of the key challenges enterprises face when adopting generative AI? If you could throw some light on that as well.
Sure. So the first thing is, the viability of the use cases, because there is a lot of hype around generative AI. People are not clear on where to use it and where not to use it, right? So that is a challenge because there aren't, and that stems from the fact that there aren't enough people across the industry and even consulting firms, if I may say so, who understand this technology really well, right? So that's the shortage of manpower, the ability to identify use cases, and then be able to quantify benefits. And this goes to your earlier question of how it aligns with organizational goals. That is a challenge, that most organizations are facing today. The other thing is that even with generative AI, there have been, incidents which are unfortunate, like Amazon Q sort of giving up locations of AWS, wherever they're hosted, the services, right? These are supposed to be confidential bits of information. So the whole piece around the confidentiality and, that my information is not going to sort of end up with someone else, right? Information that I use with the model to answer a question, it should not be used to train the model, and then it should not come up with when some other organization is trying to get a question answered, right? So that's another challenge. So convincing stakeholders, especially in a regulated industry, that this is safe, that's another challenge that we face. uh, while I've spoken of higher order challenges, another challenge is the sheer availability of data. So there are two ways people use generative AI today. Either they consume APIs from OpenAI or Google or whatever directly, or they try and fine tune some of the open source models with their own data to solve their specific problems. So Bharni sort of covered this well, that your data is your mode, right? So I want to be able to get the most out of my data. uh, in a lot of organizations, data is very siloed. There it's very hard to sort of see governance across different types of data. So structured data, tables that he mentioned, there is some order that is in place across more organizations. But when we come to documents, SOPs, there are so many versions. Who keeps it up to date? Images, if they are being used, right? Generative AI can consume any form of data. So that's another big challenge, the availability of high quality data. And the last one I would want to highlight, uh, actually there are two. One is, how do you take something like this, and what Bharni showed was pretty complex, and then that has to sort of integrate with what I already have, right? So if I've used that entire complex architecture that Bharni showed, and I am trying to use it to say get info, to use it to make a loan decision, right? There are many documents you submit when you take a loan, and I have to extract that information and summarize it. So this has to then go into that existing sort of tech landscape that I have, whereby my loan decisioning, loan disbursement and all that happens. And lastly, and I think Bharni covered this also, the last thing I want to cover is, when it comes to machine learning, MLOps is a fairly mature practice, right? But today, when it comes to LLMs, that entire observability space, knowing, how my model is drifting, like it's not giving answers as it is supposed to, that is a fairly new area. That's an evolving area. And that itself brings its own set of challenges, because we get to know sort of after the fact that once people start seeing the output from the model, that model performance is not what it should be. So I think broadly these are the challenges that exist today.
Perfect, Shivatsa. Thank you so much for throwing light on that. Ashwin, we've heard about the challenges as well, and most of them seem to revolve around strategies. So, what strategies should organizations employ to successfully navigate the adoption challenges that Shivatsa mentioned, and some that you also might have in mind?
Sure. So to start with, one of the key things is use case valuation, right? So
Hmm.
that's a big problem that I've seen with a lot of enterprises that have spent 6, 8 months building stuff and then realizing that, oh, what this does not really is not the value that I would have expected, right? Like it is not showing the same value that I would have, kind of got with the existing process, right? So going back to the hiring example, so one of the key things we employed there was how do you first capture the existing, time spent, right? The turnaround time spent, or the quality of profiles that were given, right? So you baseline what is the existing process and its metrics, business metrics as such. So very, very important step, because otherwise, given the hype that's around generative AI, everybody in business wants to leverage it, and that central group that is sitting and trying to serve all of them is under tremendous pressure to think, okay, which one to serve, which one do I reject, right? So two key strategies that I've seen work. One is capture value, the existing value, and see how will this technique actually help you change the value dimension of it, right? The second is create a prioritization matrix, right? Typical prioritization matrices that we always worked with had two dimensions. One was valuation and the other was feasibility. So the third dimension gets added with generative AI coming in is risk. So the biggest thing that enterprises need to think is, by executing this use case, what are my risks of executing and what are my risks of not executing it?
Hmm.
And that's very, very critical, because that's a dimension which, with typical use case prioritization frameworks that I've seen over my career, we always took only two dimensions. We took valuation. Typically we said, okay, we will map it to the organization objectives, all of that, right? So we know that we are hitting to what the enterprise wants to achieve. And then we said, okay, feasibility, right? Like in this scenario, it is about feasibility in terms of data, availability in terms of technology, availability, and in terms of people, right? Who can validate stuff that we're throwing out or delivering as such, right? But the third dimension of risk was never something that we looked at. And that's something that's gaining a lot of traction, because understand one thing, that there are a lot of ethics, there is a lot of governance that's, every country is going to come out with, right? Like, be it the EU AI Act that's already in play in European Union, or India coming out with DPDP. I know the elections is over now. Hopefully, they will launch this, the DPDP Act. So very soon, enterprises will be in the middle of understanding risks, meaning valuing risk a lot more. So this is one of the key things from a valuation standpoint that I wanted to kind of put through. The other important thing is data, right? Like which Srivatsa mentioned. Uh, a lot of enterprises we see their data is not AI ready. So what I mean by data not being AI ready is people knew where the data lie. They
Hmm.
used to create their reports, dashboards. They knew that this is the data I want to use for training a model, a traditional model, for instance, and stuff, right? That was the scenario. And they trusted it because it was the central team that was doing it. Now with generative AI, what has happened is the delivery of these application itself has moved to the edges. So people in the business side of the house are trying to build these applications. It's no more a central data AI team that is sitting and delivering these applications. So how do you ensure that your data is AI ready? Which means, can I discover the data? Like, the bot that Srivatsa was mentioning, right? Like if it has to go and fetch your enterprise data, it has to fetch it based on natural queries that are coming through, right? Like somebody saying, okay, what's my account balance? Typically, non-AI ready data would not have any description that says that, okay, this column in your database actually means balance, right? So how do you connect the natural query that is coming in with the technical query? So that is one dimension of discoverable, which enables what is called discoverability of data. And the second important dimension is trust, right? So this is something that we talked about because data is continuously changing. It is not going to change, stop, right? So how do you ensure that you're constantly monitoring and measuring trust of a data product or a data asset that you have so that any model that is actually leveraging the data is using data that is trustworthy? And the third dimension is privacy, right? Which is going to be extremely critical with acts like DPDP coming in. How do you ensure that the model is trained on data that does not have any PII information?
Hmm.
This is very, very critical because yes, you can happily train your models in PAI, but when it comes to the regulator, he's going to come behind you and say that, okay, you should probably not have used it as such, right? So how do you obfuscate PAI data? How do you ensure that data is obfuscated before it is launched, right? Like these are critical dimensions. And the last thing I would also have seen coming up now a lot more is there is a risk council that is getting created within enterprises. A risk council is a body that is going to consist of people who are from technology, data, business, but also legal folks. Because one of the key things is models used to be within the perimeter of an enterprise when it was traditional models. Now, models have moved beyond the perimeter of an enterprise. So, if a model, for instance, let's just take an instance that it gave a response in a bot during a conversational scenario, and that response is led to something untoward, right? For instance, who takes responsibility of that scenario, right? Like, is it the enterprise or is it OpenAI, which probably in this, I'm just taking an example of OpenAI, nothing to do with OpenAI, but they've used OpenAI to deliver this, right? Is OpenAI going to take the responsibility? So these are very complex questions that a risk council has to actually, come up with an answer. So these are some of the key things that I feel enterprise is starting to do a lot more.
So the risks associated with the projects that we take up, the guardrails that need to come up as well to supplement and complement the projects as well, so that there are no biases, there are no hallucinations, or your patent to not be leaked as well. Most importantly, what should organizations do and what shouldn't be done with generative AI and the risks of either sides? Thank you. Thank you, Ashwin, for that. Now, when it comes to risks as well, Srivatsa, if you could throw some light on critical risks that you envision that can come up with Gen AI adoption as well.
Right. So, okay, I can think of a few risks. So first, I think one of them Ashwin has covered. So I can talk specifically from our industry. We have a lot of documentation that has PII, like PAN, Aadhaar, your date of birth, right? And many a time we try to use LLMs to sort of query these documents, and that's a big risk, right? So how do I make sure that the PI data is tokenized and I only send some dummy data? So that's a risk. So you need a very strong framework in place in terms of what actually goes to the LLM. So when people think of Gen AI, they just think of Chat GPT and I enter something, I get a response. But there is, as Bernie also showed, there's a lot of things that go in between. And guardrails you mentioned, making sure information is not leaked out, abuse, right? Abuse prevention. All of these need to be built in. So these are risks, right? So like Ashwin gave the example of the chatbot, if it's a customer facing, what happens if it ends up abusing a customer? Or
Yeah.
because the customer uses abusive language, it responds back in the same language, right? These are all real problems that we need to sort of focus on. The other thing is, bias, right? So I spoke about fine tuning of model. Now, and again, there will be bias in the LLMs when they are sort of already being built, right? And in
Mm,
top of that, if there are biases in the training data, right? It could be, for example, if I am uh, sharing some past complaint data, and then I'm excluding some form of complaints that has actually happened in the past, right? And I'm sort of biasing the model in terms of the data I've fed it and how it responds, right? So, or worse, if I'm using it for to decide who to give a loan to or not, and then I'm taking in, features like race or caste or something like that, and you may find that people of a certain race in the past have only gotten loans. This has happened, right? Maybe not in India, but it has happened outside. And
mm,
if the model is trained on such data, it may systematically then start denying people loans, right? So that's again a big problem. The other thing is, sometimes these LLMs, they are trained on copyrighted data. And again, so if it uses some of that data and you as an enterprise create something or end up sharing something that violates someone else's copyright, that
mm.
again puts you at risk. Then there are the usual suspects like cyber security. So prompt injections, people can sort of hack your prompt and then make it do things that it is not supposed to do. So those risks also exist. And lastly, I think ethical AI is an important component. So how do you make sure that the LLMs, you have sufficient guardrails in place to make sure that ethical AI principles are adhered to? So some
Yeah.
of what I spoke about earlier also covers ethical AI. So, but yeah, these are all real risks that organization need to factor in when they are deploying Gen AI in production.
Noted, Shweta. Yes, the biases risk is so real, and we're seeing it happening in real time, the hallucination risks. And as the regulatory landscape evolves as well, it it is for all of us to sit and see how we can implement these guardrails in place as well. Thank you for throwing light on these important topics. Now, Ashwin, I'll come back to you again.
Mm.
You heard about the risks. What are the weapons in our arsenal to mitigate them?
So one of the key things that Barney mentioned earlier was observability, right? Like he talked about observability, but when it comes to models, right, there is a lot of model observability that ML ops is what we talk about. But how do you do that in an automated and a centralized fashion, right? Like so basically take a look at your entire data, right, that is there in your ecosystem and constantly have something that looks for biases within different, elements within your data sets, right? Like so it is constantly monitoring it. With regards to responses, right? So if you look at from a response standpoint and a request standpoint, prompt injection standpoint also, there are things like NVIDIA's NeMo. That's one of those frameworks that we have started to leverage. Basically, what it does is it ensures that it avoids prompt injection, or it validates the response, right, for all this kind of causity, all of those kind of things that we were talking that Srivatsa was actually mentioning, right? So that is one. The third dimension is copyrights and ethics, right? Like that is one of the key things. So one observation we've had is while a lot of product design teams are trying to kind of build use cases using generative AI, one of the key things they have to keep in mind is and this is something that you do upfront, right? Because copyrights is not something that you can, kind of do later on. The only thing that you can do is watermark checking and stuff like that in an automated fashion. But it comes into your strategy phase where whenever your valuation of use cases or prioritization of use cases is happening, this dimension is something that you would have to look for. Whether by implementing the use case, the risks that I talked about in is one of those dimensions in prioritization. Ethics and copyrights are clear risks that people have to start measuring at that point itself or visualizing. And that's where I said a risk council. When I said it's a risk council, it's basically something that's centralized with people from different functions as such, because that is when that collaborative knowledge is something that's required to understand ethics and copyrights better. It's probably never going to be a techie who's going to understand copyrights and ethics. It's going to be a more of a cross-functional team that's required there.
And as you guys mentioned as well, that the council needs to come in. The councils will be formed, in fact, Srivatsa, and you also mentioned to, and it will have various people from various designations. The entire C-suite will be involved to better understand the nuances of it. Thank you for throwing light on that. Ashwin, stay with me here because now I'm going to ask you the important question. Uh, I read a report which said this is the year finally India is going to realize the return on their investments and the energies they've invested in AI and projects. Sure, leaders are definitely experimenting, exploring. We are ahead in the race, but a lot of them are in the proof of concept phase. Now, what strategies can organizations use to move these projects which are in the proof of concept phase to deliver production grade use cases? What do you suggest? What are the strategies?
So three key things, right? One is the use case prioritization validation framework that I've been talking about. That is very, very important.
Yep.
The second important thing that is validation of the outcomes, right? Because yes, these are probabilistic outcomes. They are not deterministic in nature. But how do you use the ground? How do you create ground truth that you have in some form or fashion, right? Like let's take the example of the call center that Srivatsa was talking about, right? There is lot of ground truth that exists in the conversations that happen today in a call center. That becomes your validation ground truth that you
Hmm.
have to use against the model, because that is one of the biggest factors I see enterprises not wanting to press the button on production, because they're not sure, oh, what output is coming here, right? Like, okay, are you sure that it is giving accurate answers, right? And the best way to validate it is to kind of reflect it back on your existing process, your
Hmm.
existing this thing, and see how it is behaving,
Hmm.
right? That's very, very important. The third important thing is another thing that Srivatsa told is how do you it fit into your existing business process? So you will need to completely reimagine your business processes. A lot of enterprises think this is going to be something that's going to just come and attach, right? Like it's not going to happen. You will need to rewrite your standard operating procedures. You will need to reimagine the entire business process. You'll have to kind of train people to do higher order tasks. This is a big thing because job loss is real, right?
It
But
is.
how do you handle job loss, right? Because the best way to handle job loss is to enable people to do higher order jobs as such, right? So that they benefit and the enterprises also benefit. And that's something that we constantly observe. And finally, building that automated observability framework for multiple dimensions. The dimensions that we talked about is model observability, data observability. We've been talking about it all through. A third important dimension is financial ops or FinOps that we call, right? Because one thing we have to realize is a very costly tool in the hand of people. And if you just like cloud, right? I see a lot of enterprises today who have implemented cloud over the last decade, right? Come to us and say, you know what, my cloud costs are just booming out because people are
Mhm.
just leveraging these models for all business function folks are using these models for doing their job, right? Like trying to do their job. They think they're doing it. But what they're doing is actually shooting up the costs.
Cloud costs. Mhm.
So a FinOps, which is automated in nature, that tells you that, okay, this is what you felt this is going to take when you designed it. Is it there? That is the right side, right shifting of it. But there is a left shifting of it also we see when we implement it, where whenever people are writing code or, developing these apps, how do you proactively tell them that what they are doing, what tools they are using are not the right tools, they're better tools, more cost optimized in nature. So these are some of the, strategies or techniques that we would use.
Quite a targeted approach in that case. that ultimately leads to optimization. Perfect. Ashwin, Srivatsa, I can't thank you enough for throwing light on this important subjects. And I'm sure it benefited the audience much. What it has also led to is more questions coming up in the chat box for Ashwin, Srivatsa, and Varni to tackle. So we'll go through it one by one. I will frame the question. You guys take a decision on who gets to answer this. Atul Kumar wants to know, is it dependent on customers' need? Atul, I'm not sure if that's a question or a statement. Do reframe it and I will take it up with Bharani and Ashwin. So, what are the variable costs involved and how to arrive at total cost is Ravi's question. Ashwin, Bharani?
Sure, I'll try to take a stab and Bernie, you can add on. So major variable costs are, the requests that come in, right? So requests are not going to be in one, you can't say that, okay, all requests will have X number of tokens that it generates, right? That's a very, very variable thing that is going to happen because people will formulate like the question that was asked now, right? You can formulate it in 100 different ways. So each way that you formulate, you're going to are going to differ. So which means your tokens that are going to be taken are going to differ as such, right? So that is one of the key things that's going to change and the response it gives as well, right? Like hence what you do in a lot of these things. And the other dimension, other key important thing is, the context that you provide, right? That's a very important cost that people don't realize. Like say, just responding to standard operating procedure questions, right? If you take that as an example, the document sizes are going to be different, right? For different standard operating procedures or product documentation, for instance, right? So how do you basically, tackle it, right? Like how do you do chunking strategies and various strategies that technically we use to, ensure that your costs are consistent in nature. And then the last thing is we've been talking about conversational AI a lot, the speech to text and text to speech that we need to keep doing, that's also a costly affair, right? It's not cheap in nature. So how do you kind of consider that, and how do you draw a dimension between cost of response, coherence of response, and timeliness of response, right? That is the three axes on which we typically look at it. Bernie, you want to add in anything?
So, one of the key challenges.
Thanks.
Go ahead, nothing to add.
So, one of the key challenges with generative AI is explainability, is what Chandra says. And Chandra would like to hear your thoughts on explainable AI, which is separate from ethical and responsible AI. Ashwin, Bharani, both of you take a stab at it. Even Srivatsa, probably we can bring him in.
So there are multiple tools, libraries that we see evolving as we speak. There is a package called Giscard that is a Python library that we've seen evolving. There's another one from Seldom Core, which is also something that we've seen evolving. These are ones that are trying to provide explainability, right, to the models. The other way that typically that I've seen this happening is something that we also use for validation is a package called Raga, right? What it typically does is it takes a request from a LLM, it gets a response. The response is again given to another LLM, and the request, meaning the question, is created by that LLM, right? And then there is a similarity check, coherence check that is done based on cosine similarity to figure out, okay, did this LLM give a response that is equivalent to the other response that I got, right? Like, so that is one other mechanism that we typically see used.
Bharani?
Yeah, and I'm just going to add that this is very much a research problem. It's not solved. Not a lot of people even. So we have organically, like I said, it was an accidental discovery that actually led to all of this, right? So how does it really work? We've not arrived at that point yet. So all of these are attempts for us to make sense of, if you ask a point, let's say you were using a chatbot and you want to know how it actually responded. If you add the word step by step as a text, right? It's going to trigger the chain of action and the LLM is going to explain how it actually arrived, like a logical sequence of things it did. But that is also another prompt, right? People think LLM went back in time and introspected and gave you an answer, which is a myth. If you ask the same question again and ask it to explain, that is another prompt, that's another answer. So how it really works is still not a solved problem.
It's a wait and watch game in that case. we
It's a
will.
wait and watch. It's a wait and watch game, and that is where a lot of people are looking at small language models. They call
Exactly.
it language models, but intent is how do you get control back, right? Like how do you explain? Because this is you're dependent on a large language model that's trained on the entire WWW, right? Like and all of that, great, right? But you cannot explain it like Bernie said, right? Like so, go back to a small language model, do what it takes, but it's not an easy game, like he said earlier, train. So
Yeah.
yeah, it's a difficult game, but people start going there as well.
Bring it back locally. Train
Bring
it on your data. As you said, data
bring
is
the data, reduce the parameter, parameters on which it operates. All of those techniques are used
trillions, billions. We
there.
need to-
Yeah, the
Yes.
billions and trillions go back to millions and whatnot, I would say.
I have not heard any other word other than billions and trillions when it comes to parameters. Yes. So that's a wait and watch game. And as you said, we will need to refocus on smaller language models as well, parallelly when we deal with large language models as well. Another important question coming up, and I also appreciate this question: how organizations will manage to minimize the use of high computational and processing power that will lead to a lot more usage of energy and power that contributes to carbon footprint. So, what is the effective model to comply with sustainability? Is the question that Anish is framing for Ashwin and Bharat to answer.
Again, I think it's a multi-dimensional problem. If you use a cache and don't hit an LLM, that's the lowest hanging fruit. It's
Oh,
like
sure.
saying the fastest function is the function that never executes, right? It's no matter how you optimize. Um, and then there are, like what Ashwin is saying, there are not slower, smaller language models which are much more effective. Use that. And then there are techniques that are now evolving where, um, it is this is what is happening. People are re-implementing the inference engine in a lower level language to have a tighter control, right? What used to take a lot of resources in Python will take very few resources in C, C++, Rust. So that's also evolving. There is order of magnitude energy saving in that. On top of that, there are now chips specifically coming for these kinds of tasks, which are super specialized hardware, which are also power and energy efficient. And then the last dimension is this is where the research and money is going of how to actually generate renewable energy for the data centers, right? So it's a multi-dimensional problem. I think we are making a lot of effort, but it goes back. I would ask this question for people in the audience. If you have an unwanted tab in your browser that's consuming way more energy, so I think its ownership is on us. There is technology. There is a problem with the technology because it is demanding a lot of energy, but 50% ownership is also on us of how to use it. And are we being conscious not just on GenAI, but also on a browser tab, right?
Yeah, I think an important point that you mentioned in the last, Bernie, right? Like, can you do a task using, say, a natural language NLP model
Hmm.
versus doing it with generative AI, right? Like, those are decision points you need to keep making because there are certain things that you can still solve with a lot of the traditional models, which you can do better there rather than, using this heavy toy to do it, right? So that is one thing that I would like to add. And the other one is the context that you provide to these large language models. How do you efficiently index those contexts, right? So that whenever it has to hit the context, it is hitting it pretty straight and not, you're not having to go through hops and hops of it. So those are two key things.
So, Ashwin, Bharani, would it be right to say it has to be evaluated on a case by case basis?
It is. It
Very
is.
much, yeah. And you have to be careful in every step of the way. I'm not disregarding that these models consume power, but we can do what we can in our capacity.
Okay. But get the architecture right in
Correct.
that case
Correct.
first. So Deepak has a question on the similar vein. What's the best approach for designing and implementing the architecture we talked about, cloud or invest on GPU, and which approach would benefit on a longer run, in a longer run?
So yeah, meaning again, investing on GPU in a longer run will always be great, but you have the ability to sustain, right? because that's an effort. It's not like a simple effort where just put in a GPU infrastructure and it's going to run. I heard people from Ola having Kritim, right? Like, yeah, they are capable because they entire focus is, okay, I'm building a large language model for India, right? That is their objective. So they have the team, the people with skills, everything in place to do that, right? But can every enterprise do it? I would say that would be a big, until and unless there's regulatory pressures to do it and stuff like that. Yes, you would want to host it on your own and all of that, but otherwise, yes, you're better off to go with one of those cloud providers and execute it.
Perfect. So Barney's also answered few of the questions for the audience, and he has also provided resources in the chat box. You can also have a look at it. If you have some more questions, do contact the team. They have some resources and FAQs. They can definitely tackle it, and they'll answer to the best of their knowledge. So, with this, we come to the end of the discussion. We spoke about the architectural nuances of Gen AI, how to unlock the potential. Ashwin, Barney, and Srivatsa also spoke about strategies involved, what are the risks involved, how to evaluate the costs, how to mitigate the risks, and how to move from proof of concept phase to deliver production grade use cases. And that was one big highlight. Thank you, Bharani, Ashwin, and Srivatsa, for joining us this afternoon and for all the insights that you've shared. Thank you, audience, for your time and the ThoughtWorks team for the opportunity. See you soon. Till then, goodbye and have a great day ahead.
Thank you.
Thank you.
Bye bye.